guys, today we're going to do the Gravity and Orbits lab. So we're focusing on two things, gravity and inertia, okay? So let's break it down real quick. We are going to be talking about how gravity and inertia play a role when we're looking at revolution. Revolution, just to recap, is the act of something completely revolving around another something. Maybe say the sun, my hand could be the sun, and we are Earth, we revolve around the sun. It takes 365 days, and that is called one revolution, okay? Or orbit, that's another word for it. So we're gonna focus on how the moon orbits the Earth. My hand right here is going to represent the Earth. This hand is going to represent the moon. The moon revolves around the Earth roughly every month. Basically 29.5 days, it's a lunar cycle. So how do gravity and inertia play a role in that orbiting? That's what we're gonna find out today. So we're gonna need 4 items. You probably have them at home, so you can make this as well, to represent for our centripetal force activity, which is what we're gonna work with both gravity and inertia. The first item is a piece of string. I'm using yarn. You can use regular string, yarn, ribbon, etc. Any of that will work, okay? The second thing you'll need is a pencil. I would recommend using an old school pencil such as this number 2, and the reason is it doesn't have that piece on it that hooks onto the paper or onto your shirt. It will get in the way. So this is the best kind of pencil. The third item is tape. I'm going to use masking tape. This is what this is, but you can use Scotch, the clear tape, whatever kind of tape you have is fine. And then the fourth and final thing you may or may not have. It's these itty bitty beads. These are called pony beads. I'm using pony beads. Anything that's slightly weighted will work fine that you can tie onto that string. All right, so gravity is the force of an attraction between objects due to their masses and the differences between the distance. Meaning, what's the distance? If we drop 2 items at the same time, they both hit the ground. I'm sure you've heard of Sir Isaac Newton. I'm sure you've heard of laws of gravity. I'm sure you know that what goes up must come down. If I throw this thing of tape up, of course, it's gonna come down. That's what it does because of gravity. It's what keeps us on the ground. It's what causes objects to come back. So how does that play a role in that revolution or that orbiting period? So it's something called centripetal force. Centripetal force is going to be 2 parts coming together to work. Of course, gravity being the first one and inertia being the second. So let's build our model and then we'll talk about it as we go. So the first thing you're gonna do is tie 3 beads to the end of your string, making sure they are secure, okay? We wanna make sure they're gonna be tied on there tight. Sometimes it helps to lick the string. It will make it go in easier, I promise. Another key is if you can't get it on there, take a piece of tape, hook it on the very end of your string like this, and it'll make it where it will fold right over. And then I can slide my beads right on. Okay, so my beads are on. Now I'm gonna wanna tie my knot. Best suggestion is to tie it around, making maybe a small triangle shape. I'm gonna move my beads a little bit further down here on my string, creating my securely knotted piece because you don't want those to be able to fall off, so make sure they're secure. Then you're gonna tape the opposite end, so we're gonna need another piece of tape to the end of our pencil. Okay? Make sure that this sticks all the way out on the very end and that it's secure and that it's taped down well. All right, and so you should have what looks like this when you finish. Now, we're gonna use this model. Using the model, you wanna gently swing the pencil so that the string and the beads are circling at a constant speed. Don't swing it too hard because of course we don't want those beads to fall off. So the question is, why does it go in a circle? On your lab, it says to draw and label. So basically, what's happening? The end of the pencil, or the pencil itself, is representing what part? What do you think? If you said Earth, you'd be correct. The beads that are on the opposite end are what's going around that pencil in that revolution or that orbital path. That's representing the moon. So these two objects together are centripetal force. Inertia moves the object forward, but gravity pulls it sideways. So basically what happens is, okay, the bead wants to go in a straight path. The problem is when it hits a certain point, it can't go forward anymore. So the inertia's given way. So what's going to happen? Well, at that point, it's going to turn. That turn is from the gravity pulling back on it. That's why the moon continues to always orbit in that circular motion. Okay? So a couple of questions to consider. What kept the beads from flying away? And no, I don't mean the string, and no, I don't mean the tape. And why didn't those beads come flying inward toward your hand when you were swinging it? Why not? Why not? That's the big question of the day, okay? So then imagine that the model you just used was an actual solar system. In space, there's no string. This would not be here. So then explain how this represents the moon and the earth. Remember, I already talked about it. You could also think about it in terms of the sun and the moon, or the sun and the earth. They all represent the same motion because they all consider and do that revolution period as well as orbit. So, a couple more things to consider in your lab. Why do you think it would take less time to revolve the further away from the sun you are? Or more time to revolve the further away you are, but it takes less time the closer you are. Further, closer. What's up with that? Why? And what would happen to the orbit if the sun disappeared? If the sun is keeping all that gravity pulled in, what happens if the sun goes poof? All something to consider. Hope you had fun making your model today. Don't swing it or hurt anybody with it. But remember, this is centripetal force, the motion of inertia moving forward and gravity keeping it together in that circular fluidity. Have a great day.